Welcome to 3.2 Part 2, Writing and Solving Systems of Equations by Elimination. In Part 1, you looked at substitution. Now we're going to look at elimination and what pros that kind of has in helping solve systems. So to solve a system of linear equations by the method of elimination, you are going to get rid of one of the variables by adding the equations together. You may have to multiply one or both equations by a number to create variable terms that can be eliminated. So basically what you're looking for in elimination is you're trying to find which variable has opposite signs with the same coefficient. So for example, in example 1 here, you can see that x and negative x here, they're opposites. So if we were to add these two equations together, the x's would cancel out. That would make 0. And if we add everything else together, 3y plus 2y, we would get 5y. Bring the equal signs down. And then negative 7 plus negative 8 would give us negative 15. So adding those together allowed us to eliminate the x's, and then we're just left with y to solve for, which we would just divide by 5 to do that, and we would get y equals negative 3. Now remember, with systems of equations, you're trying to find a coordinate point. Now we have to find x. So although we eliminated it when we added these equations together, now we actually are going to need to use our y value to find x in one of these equations. I'm just going to use the first equation here, x plus 3y equals negative 7. X plus 3 times y is negative 3, equals negative 7. So x plus negative 9 equals negative 7. Add 9, excuse me, this is supposed to be a 7. There we go. Add 9, and we get x equals 2. So x equals 2, y equals negative 3. So your coordinate point, that is the solution here, is going to be 2, negative 3. All right, now we are going to take a look at number 2. 4x minus y equals negative 5. Negative 2x plus 3y equals 10. As you can see here, x has a positive coefficient here, but x has a negative coefficient in the second equation. Y is kind of the same thing. Y is negative here, y is positive down here. So we can really deal with either of these. What needs to happen, though, is the variable that we choose to eliminate has to have the same coefficient with opposite signs. So what we could do is, by looking at our second equation here, if we were to multiply that by 2, we would end up getting a negative 4x. So what we're going to do here is I'm going to multiply everything in this second equation by 2 so that we can eliminate that x value. So when we do that, we end up with negative 4x plus 6y equals, make sure you multiply the 10 by 2 as well, 20. You have to double everything in that case. And then our first equation was 4x minus y equals negative 5. Now what we do is add those two equations together. 4x and negative 4x is 0. Negative y plus 6y is 5y. And negative 5 plus 20 is 15. Now we can solve for y. Y equals 3. Now remember, we still need to find the x value so we can get the coordinate point. So y is 3. I'm just going to pick the first equation to put it into. 4x minus y, so minus 3 equals negative 5. Solve for x. Add 3 to both sides. 4x equals negative 2. Divide by 4, you get x equals negative 1/2. Negative 2/4 simplifies to negative 1/2. All right, from there, we write it as a coordinate point. So x is negative 1/2, so negative 1/2, comma, 3. That is our solution. That is where the lines intersect. All right. Number 3, 5x plus 10y equals negative 25, 10x plus 20y equals 35. You can see here our x's aren't opposite, our y's are not opposite. But what we can do if that's the case is, for example, if you look at our x's here, we can multiply this top equation by negative 2 because that will make our x, our 5x, a negative 10x. Then we would be able to eliminate the x. We could do a similar thing with y's, and actually you will see what ends up happening here when we do this here in a minute. So this equation is all doubled, so negative 10x plus negative 20y equals positive 50. Down here we have 10x plus 20y equals 35. Now if we add these two together, negative 10x and 10x is 0. Oh my, look what happens with the y's. We get negative 20y plus 20y. That also makes 0. So we're left with 0 over here on the left. And then on the right, we have 50 plus 35, which is 85. So think back to part 1. We came into a situation where we have two numbers that are not equal. So since they are not equal, it means we have two different lines, which means they are parallel. So this is a situation where we have no solution. These two lines will never intersect because they are parallel. And you can graph them to check that as well. Now remember the other two situations. I just want to review these with you. If we get an x and a y value, a point, that means we have intersecting lines. So that means we have one solution. And then the other scenario is where we end up getting two numbers that are equal, which means it's just one line. The equations are exactly the same. And that means we have infinite solutions. So remember, these are kind of our three scenarios we might run into when we're solving these. All right, let's try number 4. 2x plus 4y equals negative 8. Negative 3x minus 6y equals 12. Well, you can see here our x's have opposite signs and our y's have opposite signs, but they aren't the same coefficients. So we actually have to get a little creative on this one. Let's say we want to eliminate our x's again. To do that, we have to figure out a common multiple of 2 and 3. Well, 2 and 3, we could make these into sixes, a 6 and a negative 6. To do that, we'd have to multiply the top equation by 3 and the bottom equation by 2. So sometimes you have to multiply both equations. So this top one will become 6x plus 12y equals negative 24. And our bottom equation will become negative 6x minus 12y equals positive 24. All right, well, we know the x's will be eliminated. That's 0. Oh, but look what happens with our y's. 12 plus negative 12y is 0. Okay, so we have 0 over here. Negative 24 plus 24 is also 0. So in this case, we get 0 equals 0. So we have this situation where we get two numbers that are the same. So these two equations actually make the same line. So we have infinitely many solutions. So infinite solutions. So that is an overview of elimination. The first two problems showed you how you get the single solution. And then we used some other strategies and end up getting no solution and infinite solution. So you can see what each looks like, how they come out. All right, let's look at some word problems. Number 5, Brianna's family spent $134 on 2 adult tickets and 3 youth tickets at a carnival. Max's family spent $146 on 3 adult tickets and 2 youth tickets. What is the price of a youth ticket? So we're comparing youth tickets and adult tickets here, right? Adult tickets and youth tickets. So let's just name those variables. Let's say X is adult tickets cost. And then let's say Y is the cost of a child's ticket, youth ticket. Okay, and these are the costs of each of those because they already told us how many they bought and they're getting a total cost here. So let me just put dollar signs by these so you can keep that straight. All right. So now we have 2 different families. We have Brianna's family and Max's family. So let's try and write an equation involving Brianna's family. Brianna's family spent $134 on 2 adult, so 2x, and 3 youth. 3 youth. And they spent a total of $134. Max's family, on the other hand, spent 146 total on 3 adult, so 3x, and 2 youth, plus 2y. And that should total up to $146. What is the price of a youth ticket? So something to keep in mind here is we're trying to solve for y. We're trying to find what y equals here. We're trying to find that y variable. So let's make sure we don't eliminate that y variable, right? We're going to want to keep that. So we kind of have a situation here where nothing's opposite and these aren't the same numbers. So as we multiply these out, we are going to want to multiply both equations by a number. So we want to keep the y because we're trying to solve for that. So let's eliminate the x's. So we could multiply this first equation by 3, and we could multiply the second equation by 2, but now one of them will have to be negative. So I'm just going to make this second one multiplied by a -2. So we end up with 6x plus 9y equals, I'm not going to lie, I can't do that in my head, 402. And then our next equation is going to be -6x minus 4y equals -292. Now we can add these 2 equations together. We've eliminated the x's, so we have 0 x's. We have 9 plus a -4, so that's a 5y. And then 402 plus -292 is 110. Then to get our number of, or our cost, excuse me, of a youth ticket, 110 divided by 5 is $22. So youth tickets cost $22. All right, number 6. A caterer is planning a party for 64 people. The customer has to spend $150. A $39 pan of pasta feeds 14 people, and a $12 sandwich tray feeds 6 people. How many pans of pasta and how many sandwich trays should the caterer make? All right, so we're comparing pasta and sandwich trays. So how many pans of each do we need to make? So our variables are going to represent number of pans of pasta and number of sandwich trays. So let's just label those out. So let's say X is the number of pasta pans. And then we're going to call Y the number of sandwich trays. All right, so we're planning a party for 64 people. So we know a pan of, so there's a lot of information all at once. So let's just do the number of people first. So we're dealing with number of people. So let's write that equation first. So 64 people, we know the pasta feeds 14 and the sandwich feeds 6. So 14 times the number of pasta pans plus 6 times the number of sandwich trays is going to equal 60, has to add up to 64. Okay. All right, next, it looks like we are comparing, and I'll do this in a different color so you can see. We're comparing the cost. So our total cost is $150. Our pasta is $39, and our sandwich trays are 12. So $39 for each pan of pasta plus $12 for each sandwich tray has to add up to $150, or can only add up to $150. All right, so from there, we have to figure out what we want to eliminate. And they're asking for both variables, how many pans of pasta and how many sandwich trays. So it doesn't matter which one we solve for first in this case. So let's look here. 14 and 39, those are not going to have a very easy common multiple, but 6 and 12 will. We can take 6, multiply it by -2, and that will get us the -12y we need to eliminate that variable. So let's do that. I'm going to scoot this over this way. There we go. All right, so if we do that, we get -28x minus 12y equals -128. And then down here, we can just keep this as 39x plus 12y equals 150. From here, we add our equations. So we get -28 plus 39, that's 11. So 11x, -12y and positive 12y is 0. And this is equal to -128 plus 150, which is 22. All right, then to solve for x, we divide by 11, and we get x equals 2. So according to that, we should buy 2 pans of pasta. But now we need to figure out, okay, how many sandwich trays do we need to buy? So to figure out our sandwich trays, we're going to take our x value of 2 and use one of our equations to solve. I'm going to use the purple equation here, this top equation. So 14 times 2 plus 6y equals 64. 28 plus 6y equals 64 minus 28. 6y equals 36. Divide by 6. You get y equals 6. So we should buy 6 sandwich trays. Two pans of pasta and 6 sandwich trays. All right, so as you go forward, try and do some practice. Again, remember those 3 situations we can have, and then just be careful when you're comparing and trying to write your equations for the application problems. Let your teacher know if you need help.